In this video, we're going to go over the base data that came with your ACPF file geodatabase. This data has been custom developed by the ACPF team at the HUC12 scale.
Alright, so to get started with running the ACPF, we first have to get databases. So we'll go to our Get ACPF page on our website, hit Download Watershed Databases, which takes us to that land use viewer. To download, I'm first going to search for the HUC12 that I'm looking for. I'm going to get the HUC12 called Mosquito Creek in Iowa. Its HUC12 digit is 070802050503. And I hit search, and there it pops up. I'm going to be using this HUC12 in a majority of the videos, so if you'd like to follow along, compare results, you could download this one. You can also feel free to follow along with any HUC12 that you have on your own. So we'll go back to View and Download Instructions, hit Download Geodatabase, highlight the HUC12. Note that I'm just downloading one at this time, but you may download up to 10 at a time. I'm going to enter some general information like my name, email, and organization. This is just so the team at Ames can get an idea of who is downloading the data and who are they affiliated with. We don't spam you with email, so don't worry about that. And once you're ready, you hit download and wait a couple seconds, and here we go. It tells me I'm downloading one, and then it'll project it in my local UTM zone, and for me that's UTM 15. So I'll hit OK, and we see it opens up Windows Explorer. It tells me where I want to download this to. I'm just going to have it go to my downloads, and I'll hit save. Alright, and then once it's saved, we'll navigate to where we saved it to. That's under downloads, and I see it right here. It'll be named ACPF_HUC, followed by that 12-digit HUC code. I have 7-zip, so that's how I'll be extracting it, but if you didn't, you would just be able to select extract files and then set the location. So I will say extract files. I'm going to tell it where to navigate to, and I have that ACPF data folder on my C drive. That's my hard drive. You definitely want to save it to a hard drive location. So I'm going to put it in that folder there, hit OK, path names, everything looks good, so I'll hit OK. Then we can navigate to the data, and there is the file geodatabase sitting there. Alright, so we've downloaded our data, and now it's time to set up a folder connection. So we'll do connect to folder. This PC, I'm on my local C drive, ACPF data, and I'll hit OK. So now if I open up this folder, I can see the folder that contains my file geodatabase, and there it is. And here's all the base data that you get when you download the ACPF file geodatabase. So in this file geodatabase, we have our base data, and this is also the location where all outputs from the ACPF tools are going to be directed to. Every single data piece has a base name, and then a majority of the data is also followed by the 12-digit HUC ID. All output names will also end in this 12-digit HUC ID. When you're running the tools, you may optionally change the base name if something makes more sense to you, or say you're rerunning a process a few times over. However, make sure that everything always ends in these 12-digit HUC IDs. Some of the tools will automatically grab data and bring them in for inputs, and it's going to be looking for this ending. So it's very important that you keep that same file name structure. Alright, so briefly I'm just going to go over what is in our file geodatabase. First we have the watershed boundary feature class denoted by BND. We then have a buffered watershed boundary that encompasses the field boundaries denoted by BUF. We have our crop history table. We have a field boundary feature class. We have the GCirgo raster which contains soil information. We have a land use table denoted by LU6. This contains general land use classifications for the past 6 years. We have 3 soil tables, the soil profile table, surface horizon table, and then the surface texture table. You then have a suite of crop data layer rasters. Mine range from 2008 to 2016.
All right, so to begin, let's look at some of our boundary information. First off, we have our watershed boundary denoted by BND, followed by that HUC 12-digit code. And this has been derived from the National Hydrologic Dataset. The next piece of boundary information is our buffered watershed boundary. That is the watershed boundary buffered out 1,000 meters. And this makes sure that it encompasses all fields that lie partly within the watershed, and it's also used to clip all of the rosters to this extent. And lastly, we have our actual field boundary data set here. This was developed from the pre-2008 Farm Bill CLUs, and all identifiable information has been removed from them. And they were originally digitized to the 2009 NASS land use, however, that's being updated currently. So if we take a look at the attribute table, you can see we have a field boundary ID, so this is a unique identifier here. This will be used to join a lot of the outputs or tables to this feature class. We have the acreage of the field.
We then have an isag field, which contains values of 0, 1, or 2. 0 indicates non-agricultural, 1 indicates that it is cropland, and a value of 2 means that it is pasture. You will have the opportunity to manually update these field boundaries within the utilities of the ACPF toolbox.
All right, now we'll make our way through the land use data that the ACPF geodatabase provides. First off, let's take a look at a couple of these NASS crop data layer rosters. Each of these are developed by the USDA for each available year here. The ACPF downloads at least the past 6 years. You can see here we have a couple more than the past 6 years. And what we do is overlay the field boundary with all of these years available and then extract information by field. The NASS dataset contains over 100 values, so this gets condensed down using an ACPF lookup table. And if you remember, that lookup table was downloaded when we got the ACPF toolbox. It's right there. The next piece of land use data will be the crop history table. You can see we have our field boundary ID here. And then all the other information within this table is about the major land use in each field for each year, and then the percent of major land use that makes up. So these are all codes, and then this provides the percent that actually makes up. And you can see we have the major land use for 2008, percent that makes up for 2008, and that goes all the way to 2015 in this case.
The final piece of land use data that we have is the LU6 table. And this looks at the last 6 years of land use data for each field. Hence, we have the field boundary ID again. And it contains the general land use field, the ag land use field, which is a more detailed explanation of the general land use field. It has the 6-year crop rotation associated with each field, a crop summary, which summarizes this crop rotation, and then a continuous corn count and a mixed ag count. If you want to know more about each of these fields and how they were generated, you can go to those metadata files that was in the ACPF toolbox download and go to the LU6 file, and around page 7 you'll get an explanation of how these fields are populated and the meaning behind each of those letters, signifying the different kinds of agriculture and land use within that field.
All right, so now let's take a look at some of the soil data that you get with your download. First off, we have a GSurgo roster. And this is a 10-meter roster. It has an attribute table as well. If we take a look at that, you can see there are quite a few fields that can give you information about the soil within each map unit. And you can see it's broken down by this MU key, map unit key. And this is a very valuable field, especially when later on you'll be joining soil tables to the GSurgo roster. The next soil data set that we have is the soil profile table. And you can see that MU key field right here, so you could join the soil profile table to the GSurgo roster using this as the join field. And the soil profile table provides information at depth of each map unit. So we can get information such as available water storage and percent organic matter or coarse soils within each map unit within the soil profile table. The next table is the surface horizon table. This provides information about the surface horizon. And here again we have the MU key, so we could join the surface horizon to the GSurgo. And then we also have a co-key, the component key. And this is a valuable field if you are going to be joining the surface texture table, which is the next piece of soil information that we get. So the surface texture table tells you about the texture class and parent material. And you can see here all we have is the co-key. There is no MU key. So if you would like to join the surface texture to the GSurgo, first you're going to join the surface texture to the surface horizon based on the co-key. Then, using the MU key from the surface horizon table, you'll join it to the GSurgo. Alright, so that's your soil data. So we just went over all of the base data that comes with your ACPF geodatabase, but you may have noticed we don't have a DEM, so that means you have to go out and get your own. On this slide here, I've provided some sources that may have an adequate DEM for you, but there's many more out there to explore. Some key things to note is that the ACPF requires your DEM to be in whole meters. You also need to be aware of your Z units, and this will not be contained in the layer properties, only in the metadata. The ACPF can handle any vertical units as long as a Z factor is provided. The Z factor is a conversion factor where it is the number of horizontal or XY units within the Z unit. So for example, if you had a meters horizontal unit but then a centimeter Z unit, your Z factor is going to be 0.01. That is the number of meters that fits into a centimeter. The ACPF does tend to work better if the Z units are in centimeters. It just reduces storage requirements and any issues with quantization. Another important thing to note is that the same coordinate system must be used for your DEM as it is for the rest of the layers. The ACPF data is provided in UTM, so make sure that your DEM is also in that coordinate system. Lastly, the DEM should be the same extent as the buffered watershed boundary, so you could use the clip or mask. I recommend the clip tool to make it that same extent. Alright, so let's take a look real quick at the DEM I got. So I found a DEM, and you can see I've already clipped it to that buffered watershed boundary. And right now it's a TIFF, and it's sitting outside of my file geodatabase. I need it inside. When you run any ACPF tool, the inputs should be coming from your ACPF file geodatabase. So to get it inside, I'm going to right-click my ACPF file geodatabase and go down to Import Roster Dataset. And then I'll grab this roster and drag and drop it in. We can see it's going to the right place, so we'll hit OK and let it go. While that's running, we can open up the properties of this one and take a quick look Right now it's still in TIFF format, but we can see that I have a 2 meter. This is the horizontal unit roster. If we scroll down to the spatial reference section, I see that I already have it projected in the appropriate spatial reference. For me, that's UTM zone 15. If this was not the correct spatial reference for you, you could reproject, and I would recommend first importing it into the file geodatabase and then reprojecting from there. And then the last important piece of information is the linear unit, which is in meters. You always want this to be in meters to have efficiently running ACPF tools. So hit OK, and let's take a look at the file geodatabase, and there it is sitting there. And everything looks good to me. If we open up the properties, we can see that basically everything's the same, except for now my data type is a file geodatabase roster dataset, which is good. Here's a brief recap of everything we just went over with your ACPF geodatabase and DEM download. Now it's time to move on to running some of the ACPF tools.